Good morning, everybody. Buenos días a todos. Welcome to the webinar ENZYCLE project, the power of the enzymes put to valorize multilayer packaging and microplastics. Welcome to ITENE. Today, the webinar is follow us online, and we are here in Valencia. My name is Carlos Monerris, and I am business director at ITENE. And first of all, I would like to thank the 13 partners of the ENZYCLE project. We would also like to thank bio-based industries joint undertaking and the Horizon 2020 of the European Union for supporting the realization of this project. Let me start my speech greeting those who are with us today in order of appearances or decisions. Chloe Johnson, the bio-based industries joint undertaking project officer, and who will start the meeting. Licinio Diaz, head of industrial and environmental biotechnology unit at ITENE and the ENZYCLE project coordinator. Christian Soberker from the University of Leipzig. Gerald Strittner from the University of Natural Resources and Life Sciences of Vienna. Tom Ewing from the Stitching Weaving Research. Maria José López from University of Almería. Marta Redadro from ITIP. And the last one, Beatriz Domínguez from Oceanographic Foundation. Many thanks to all of you for participation as a speaker in this webinar, which serves as a meeting point of the biotechnology sector. As I have just said, we are attending this event from different localizations. I am sure that this will be a fruitful meeting to share views and discuss that the ENZYCLE projects can bring to the table. ENZYCLE is going to make a relevant contribution to the circular economy, thanks a new process to enzymatically recycling plastics that currently are not recyclables, such as PET trays and clam shells and PET, PP, multilayer packaging. Biotechnology also enables us to obtain and have high-value active products, including polymers with properties similar to virgin polymers from plastic waste. At ITENE, we perform enzymatic recycling by identifying and developing microorganisms and enzymes of interest, retreating and conditioning waste and polymers, developing, validating, and upscale depolymerization processes, purifying and added value products, and developing downstream products purification processes. We also provide technological support to companies in areas such as packaging sustainability and materials development to help them face the challenges of these times of change. They are exciting times in which to make a difference, and I hope that today's event will help us to learn through the debate and the contributions for all people who will speak today. And I give the floor to Chloe Johnson, the bio-based industry joint undertaking project officer, and thank you very much.
Thank you very much. So I'll just share my screen. I think you need to give me permission. Yes, here we go. So bear with me while I share. Okay, so I think you can currently see my screen, so I will go ahead and share the presentation. Please tell me if you can see it.
Yes, perfect.
Fantastic. Okay, so first of all, thank you so much to the organizers for allowing me the opportunity to be part of this event. My name is Chloe Johnson, as was mentioned, and I'm project officer at Circular Biobase Europe joint undertaking. And I have the privilege of being project officer to not just ENZYCLE, but also Recover and Bizenza, who are represented here today. So we'll hear from them later on and the great achievements that they've achieved so far. So first of all, I just want to say some words about who we are at Circular Biobase Europe, for those who may not be familiar. We're a 2 billion public-private partnership between the European Union and the Biobase Industries Consortium. And BBI JU was existing to support the development of a sustainable and competitive bio-based sector in Europe. And now CBE JU is building on the success of BBI JU, and also in doing so, stepping up the contribution to the EU's climate targets. So some of the aims we can see is to increase the sustainability and circularity of production and consumption systems, to develop and expand the sustainable sourcing and conversion of biomass into bio-based products, and to support the deployment of bio-based innovation at regional level. And if we take a look at some of the general objectives, it's to accelerate the innovation process and development of bio-based innovative solutions, and then to accelerate the market deployment of these existing solutions, all while ensuring a high level of environmental performance. So why continue to invest in a bio-based sector in Europe? Well, it's because it is expected to allow replacing 25% of oil-based chemicals by 2030, creating up to 700,000 green jobs, but also drastically reducing our dependency on strategic raw materials, for example, proteins, phosphorus, and potassium. But very important in the context of the European Green Deal to also significantly reduce greenhouse gas emissions. So here's a snapshot of some of the achievements of the BBI JU. It has a portfolio of 142 projects with more than 1,000 beneficiaries, in excess of 800 million in funding, with these beneficiaries spread across 39 countries. And one of the aspects that is notable is the very high participation of small and medium-sized enterprises, which are in fact 40% of participants in BBI JU projects. And this accounts for roughly 30% of the funding. And this is very important as it's clearly has attracted these entities as it helps them to scale up technologies and also gain further access to market. But another very important element, which can be seen in some of the projects you'll see later today, is the strong collaboration between universities and academia and industry. And these entities, universities and research centres account for 30% of the participation. And this is very important to trigger, in fact, innovation. So one of the most visible achievements of BBI JU is the flagship projects. And these are so-called first-of-their-kind biorefineries in Europe. And they operate or will operate at a pre-commercial scale. And they're exploiting local feedstock to produce innovative bio-based solutions. So here's just an idea of how they're spread across Europe. But what's also notable is the expected socioeconomic impact of these projects. So they're expected to create a significant number of jobs in the range of 20,000. And also an important element is the triggering of investment from the private sector. So this leverage effect is expected to happen with the flagships that for every €1 of BBI JU grants, it's expected to trigger more than €5 of private investment. So this is really an indication of how it's mobilizing the sector. But in the context of the Green Deal, we're also interested in reducing CO2 emissions. And this is quite notable with the 13 flagships alone expected to save 800 kilotons of CO2 emissions. But also the aim of BBI JU is to increase the deployment across Europe. So it's also important that these flagships have a high replicability potential. But that's just one type of action. So we also have other projects that are operating at different technology readiness levels. And the projects we'll speak about today, ENZYCLE, Recover, and Byzenta, are research and innovation actions. And these also play a crucial role, and they operate between TRL 3 and 5, and are engaged with the development and validation of technologies. And in this way, they're making a strong contribution to the BBI JU objectives by demonstrating new technologies to fill gaps in value chains. And so today is about, well, in part about these 3 projects, which are all tackling a very important challenge. So they were challenged with applying microorganisms and enzymes to resolve end-of-life issues of plastics. So here we're talking about non-biodegradable or non-recyclable materials by currently known methods. And they're all bringing their own innovative biotechnological solutions to achieve this. And what's notable about these projects is they're very complementary. So they're all tackling different materials, and in this way, creating synergies and interactions between them. So we're very proud to fund these 3 projects because they're all actively contributing to a circular economy by valorising streams that are traditionally waste. So this is why it's very important to us at BBI JU, because in the end, circularity is at the heart of the new partnership. So I won't take up more of your time because we're all looking forward to hearing now from these projects directly and how they're going to bring us forward into a more green and sustainable future. So thank you very much for your attention.
Thank you so much, Chloe, for your presentation and also for having you here in this webinar. Well, we will continue now after this. Yes, after this great introduction, now it's time to move into the ENZYCLE project. The idea is to have a very brief overview of the project, the partner consortium, our objective that we have. Later on, 3 of our partners will show the main development that we are achieving during these first 2 years, the first half of the project, and later on our colleagues from Recover and also Vicente will explain and we show the project and also the collaboration that we are maintaining during this time. And finally, we will have, as Carlos commented before, the participation of oceanographic, in which we will put in relevancy the impact of the microplastic, so the importance of developed technologies that allow to solve this problem. Well, as you know, as you know, ENZYCLE project the idea is to develop new enzymes for the treatment of different plastic fractions that are currently not recycled. In that sense, it's important because it's our main issue that deal with those fractions that today by mechanical recycling, by chemical recycling, is not able to be recycled. And I think taking advantage of the properties of enzymes regarding the substance specificity, well, it's a good opportunity to explore and to implement this technology into the recycling sector. Well, this is the main part of my presentation. As we already know, we are totally aware about the problems that we have today and the amount of the plastic that are generated. It's a pity, but this is not valorized. In that sense, it's estimated that it has a huge economic impact, almost 20 billion euros, and also the environmental impact that we have with the emission of greenhouse gases and specifically CO2. In that sense, this project, the idea is develop these new enzymes and new biotech processes for the treatment of multilayer packaging, mainly composed by PET and polyolefin layer, for consumer polyethylene terephthalate trays, the PET trays and clamshell. You already know the problems that the waste manager has with this kind of packaging, for instance, because in the sorting plant is quite difficult, almost impossible to sort. And for this reason, this packaging goes to the landfill. And finally, we have an important issue in which we want to deal, and it's the microplastic pollution that also have impact, not only environmental but also in health, and even more and more in the news and so on. We are we are aware of the risk of the microplastics in our oceans. Well, we are very proud of our consortium. You already know this is the main partners that compose this project. In a very brief overview, we count from Germany with Asad Enzymes and University of Leipzig. They are quite expert in the production of different enzymes and the development of PET enzymes. From Netherlands, we count with Indorama, is the major PET producer in the world. With Fayecon, they are quite expert, with a very best expert in CO2 technologies, supercritical CO2 and this kind of aspect. With Wageningen, they are also a very named university that will be in charge of the process development and also in cooperation to the different polyolefins enzymes development. We count with Suprema. They are also they are company related with polyurethane insulation foam, and different technology for recycling these polymers. We count with Greiner, it's a huge packaging manufacturers, one of the biggest in Europe, with ACID, the Industrial Biotechnology Institute in Austria, and BOKU, the University of Natural Resources in Vienna, that they will also work in the same production, new technologies for the same production, and they are coordinating also the communication aspects. Aliglas is they belong to Group ERA in Italy, and they are huge waste managers that also put in the context all these problems in the project. We count also with in that sense in Spain, from Spain, with RAM, the Polyolefin Agua de Mediterráneo is a large company, the representation of the waste treatment, and more focus in microplastic pollution. We count with Darwin, it's a skilled SME here in Valencia. They are expert in prospection of new microbials, of new potential industrial microorganisms. And the last, we are in ITENE, we are the coordinator of this project, and we are focusing in different parts of process development and also the LCA analysis and so on. Well, this slide is a bit messed, but the idea is to show that with this project, with the ENZYCLE project, the idea is to cover all the value chains of the enzyme development. For sure, we start from the discovery of new potential microorganisms in which we go into them to analyze, to identify new potential enzymes for the treatment of PET and polyolefins, in which we clone, we select, and we modify in order to extract and produce by new technologies like continuous production and so on. Afterwards, we want to develop all the process for the polymerization of our targets, the multilayer, the PET trace, and microplastics. And finally, we want to perform different proof of concepts. In that sense, with the monomers that we will obtain from the different polymerization processes, we will perform new PET, I think proof of concept in new packaging and this kind of aspects. In that sense, this is the main objective of ENZYCLE, as we commented before, is the development of new enzymes and the processes for apply those enzymes to the treatment of non-recyclable plastic fraction. In that sense, I have to say that our idea is not be a competence between mechanical, chemical recycling. I think that we have to implement synergies with that. I think that is the good path to focus on that. Well, this is the scheme, a simplified scheme of the project. This is very clear, the 4 line of work. I will try. Okay, we have in this part, we have all the branch that are connected with the enzyme development, in which we perform different omic analysis to identify the potential microorganisms. We isolate, evaluate, and select the clones, and also to be in line with the production, encapsulation, and so on. Afterwards, we have the multi-layer packaging workflow in which, well, we will implement new pretreatment in order to enhance the polymerization of this target. And the idea is to have two approaches. One more conservative and one is more challenged. The more conservative one is, well, in multilayer packaging, the idea is to depolymerize only the PET layer, and from one side have the monomer from PET and the pure layer of polyolefins, which will be recycled by mechanical recycling. The second approach that is more challenged, and I think that we are in the good way, is depolymerize both, all the PET layer and also the polyolefin layer. With PET is clear, it's the polymerization to obtain all these monomers, and with that, with the phthalic acid, the idea is to synthesize again new polyols that will be used for the polyurethane synthesis. And for monomer that came from PET, for sure, we will repolymerize into new PET. In terms of microplastic, we focus strongly in this sector. We have three developments. One is a microplastic degrading system in which the idea is to use these enzymes together with the wild types in order to have some system that allow to degrade the microplastics. The idea is to transform in biodegradable molecules that will be, I think, a little bit safer. We will also include all these processes in the anaerobic digestion in order to enhance the production and avoid the flow of microplastics into the digestates and also the composting of that. And for sure, in the last part, we will use these strains and also the enzymes in composting processes in order to avoid the spread microplastic in the compost when it's applied to the agricultural sector. More or less, in a few words, is the project. Regarding the impact, well, we commented a lot during the presentation, is the decrease of amount of non-biodegradable polymer that is put on the market, and also the reducing the cost of the treatments. I think that is a key point. The creation of new markets, the recycling, traditionally, the recycling sector is dominated by mechanical or maybe by chemistry. With these approaches, we demonstrate that biotechnology will be applied also to this sector, and we'll try to do our best. In that sense, also, we want to enlarge the range of feedstock able to be effectively and sustainable processes through biocatalytic systems, lay the basis for further exploitation at the higher scale of microorganisms and enzymes for this application, and increase the incomes and business opportunities. Also, not all the stakeholders that you are already here, but all the actors in the value chain, and for sure create new job opportunities